Hello friends, welcome back to the bench. Our patient today is a 2006 Tribeca, which is a project car that Keith is working on. And if I don't forget, I'll show you the picture now. It's a beautiful car, especially when you see it on the with this landscape behind it. It's a beautiful car, no wonder it's a project car. Now it's misfiring. I don't remember which cylinders, but I do remember it's intermittent, meaning when you warm it up, when you start driving and it warms up, especially when you put heating, the problem kind of goes away after a few miles. Classic symptom of a IC608 problem. So we're gonna perform a 5-minute repair on it. It is called 5-minute repair because it takes about half an hour when you're good, and it takes over an hour if you have less experience. And so what we're gonna do is just take off the chip, clean the solder, clean the board, clean the chip, apply new solder, solder it back, and seal it. All in 5 minutes. And well, what was it? The students 5 minutes. I don't know if that translates well, but it's basically a 5 minutes with a big margin. And since Keith is a sponsor of today's video, because not only I got paid in cash for this one, but I also got a tip. I haven't had a tip in decades, because I used to work in the industry of, I was a busser, server, liquor store clerk. So I would make some cash tips back in the day, and I always loved that. It always feels so good when you walk out of the job and you have cash money in your pocket and IRS has no idea you do. I always actually wondered about that. Like, did they not? Because you don't report this cash money, because you only report the one that you get from the credit cards, right? Because you have to, because that's gonna show up on your paycheck. But the cash, if you don't report it, well, what are you gonna do with it? You're gonna take it to the bank. So either way, IRS would or could know how much money you're making based on your account balance, your deposit history, that kind of stuff, right? So I don't know, they just don't care, or it would be not practical to just chase after those. And at the end of the day, it's not the huge money we're talking here, right? But since Keith is the sponsor of today's video, let's talk about the subject that Keith is interested in, which is solar panels. And actually, I had a subject in mind for today's video, but when Keith suggested the solar panels, it occurred to me that actually there's like plenty of misconceptions when it comes to solar panels. And is it a free energy? Well, yeah, it does. They do generate power seemingly from the air, There are no moving parts, right? So it's not like you have to replace the bearing every 10,000 rotations or whatever, like you would in the generator, like maybe wind turbine or a turbine on the river or something like that. If there are moving parts in anything, then that's gonna have to be maintained, right? So you're looking into some maintenance. With solar panels, you just kind of put them out there, and they just work, right? Also, from the generator, from the turbine, you get AC signal, right? So after the energy is generated, now you need to run it through some rectifier. Maybe you need some smoothing caps, then some kind of stabilizers and stuff, some kind of power converter. It could be a pretty complex device. And from solar panel, you get beautiful, steady DC voltage. You can actually connect it directly to your car battery to recharge your car battery. If your battery died for one reason or another, and the battery is functioning, it's just drained. Yeah, you connect the solar panel and directly to the, as long as it's a 12 volt solar panel, and usually they come, especially the ones that are kind of designed for this purpose, come with a nominal voltage of like 13.5, something like that, 13.8, 14.4. So you can connect them directly, no additional equipment, just some sun and a lot of patience. Unless the panel is really big, but even if it's big, it still takes quite a bit of patience. So that is definitely an advantage when it comes to panels, but efficiency. Are solar panels efficient? No, solar panels are kind of like the least efficient way of producing energy. It's just very convenient. Well, convenient in the manner that you get DC voltage from them, and you don't have to really do anything to them once you set them up. You do need to replace them after like 10 years, but before then it's like you don't have to do anything to it. But they are inefficient for two reasons. Well, funny fact about the solar panels: they need sun to work, right? I don't think that comes as a surprise, but you might think, okay, if they're not directly in the sun, they're somewhat in the shade, or they're not facing the sun exactly, they're still generating some energy, right? You would think maybe 50%, maybe 20%, maybe 30%, but they are actually generating 0.3 to 0.5%. 0.5% is like the maximum you can get in certain circumstances, and actually when it's overcast you get that. Meanwhile, look at this solder. That was see how brittle it is? That was the problem. There's your problem, Keith. Okay, let's we have focus here. Good enough, right? So, if not facing the sun exactly, they will generate anywhere from 0.3 to 0.5% of the nominal energy that you expect them to produce. So you need to put them in the sun, right? But there's another funny fact about the solar panels. They actually reduce efficiency. The efficiency drops when they get hot. So you better keep them in the shade, right? So they don't overheat. But in the shade, they don't generate energy. So you can see kind of a catch-22 of this problem. Any kind of cooling devices, I've never seen anything like that. But I was thinking, you can't really run water through the panel, meaning on the top of the panel. But perhaps maybe if behind the panel you run some kind of liquid, some kind of cooling liquid, maybe that would improve efficiency. But then you have hydraulics, right? Then you have actual maintenance, right? So it just kind of defeats the purpose. So if that be the case, then it's better off just using wind turbines. They're much more efficient, especially considering how much room they take. Unfortunately, solar panels, if solar panels were white, they would not absorb as much energy in the form of heat. But they are dark, very dark. So they will heat up. Now from the sun, you get, that energy you get that is converted to the electrical energy. You actually use the tiny spectrum of that. The rest, the especially infrared, that is responsible for actual heating, that is not needed, and it works against efficiency. So that is a general problem of solar panels. They work great in space. However, in space you don't have to worry about the atmosphere, right? You get more direct sunlight, but you have the same problem with heating, and they heat up over there even more. However, although it's cold in space, right? But since there's no air, nothing to just kind of take away that thermal energy, you actually, there was, like, you've seen this in the movies, like or older movies. I remember this scene when the guy opens his helmet in the space and he's like instantly freezes. That would not be the case, because there's not enough conductivity of that heat to just kind of suddenly escape from your body, because you're not physically touching anything, right? So it's only your skin that will start losing heat very slowly. So you will suffocate before you freeze if you open your helmet in the outer space. So all that heat is unwanted. We don't want that heat. Oh my god, this solder is just awful. Look at this. So, what was my last point? Because I already forgot. That panels are heating, which drops their efficiency. Yeah. But that's not even the largest problem, because there was this idea, some Kickstarter, making solar panels like kind of rotating and so they don't heat up. That's not enough gain. Even if you keep the solar panels cool, it's not like it's a huge game changer at this point. There will be a slight improvement, obviously, but it's not a game changer. And all the complexity added to have the cooling for the panels, it's just not worth the effort, not worth the reward you get. So panels will heat up, but the main problem is that they need to face the sun directly. So if you're thinking of putting solar panels on your roof, which is pretty popular and it works, but be aware that without actually having positioners for those panels, so they track the sun, just facing a single direction, your peak efficiency will be maybe an hour in every day. I mean, throughout the day, if they're facing south and they're at the angle, because usually the roof is at the angle, they will still be generating some energy, but the peak performance, because when you buy a solar panel, you get they give you a wattage of the full installation, right? So say it's 100 watts to make the math simple. 100 watts, right? Obviously that would not be worth it putting on your roof. In fact, you can get a 100 watt panel as a single unit, and even it goes even higher than that. But say it produces 100 watts. Now in the morning, when the sun is just above the horizon, you're gonna be producing 5 watts at the most. That's 5%. Then throughout the day, until the sun is in the perfect position, you're gonna be making anything from 5 to maybe 30, maybe 40, and that's pretty much it. And then for an hour during that day, you're gonna be making 100, maybe for an hour, maybe less. So looking at it this way, you're actually getting the energy only from a sliver of a day, of each day. Yet you have this belief that my installation is 100 watts, and it is, and it would be producing that much for most of the day if you had a tracker to position that panel to always face the sun. That can be done very easily and relatively simply, because you don't exactly need a sensor to track the sun, because the sun will move the same way across the sky every year on the yearly cycle. So basically the sun tracker is basically a clock. So you just put the panel on it and you tell it what time is it and what day of the year it is, and it will know when to position the panel, because it will know where the sun will be. However, that is added weight, that is added complexity, obviously, and that is added maintenance. So it kind of again kills the idea. It kills the idea of a maintenance-free device that generates energy, which is what we want from the solar panel. The main misconception is around the power it produces. And I have I have several of these, because I was always into energy production concepts, and I have some of my own ideas, and some I've tested, some I haven't. The ones that I've tested are not exactly practical, although it works, it's just not practical. So it's kind of a hobbystic ideas. But a friend of mine that was back in Wyoming, winter time, he got these LED Christmas lights that he hung outside, and he connected a solar panel to it to recharge it. There's like tiny battery in there, and the solar panel to recharge it, or the solar panel was added by him to recharge it, and it didn't work. And he asked me about it, like what could it be? Why would it not work? Or it worked for like a day and it doesn't work anymore. So obviously my first question was, what's the power consumption of the Christmas lights? Unknown, but we can assume, the quarter watt per Christmas light, maybe, right? And let's say there's 20 of them, so we can estimate roughly what the power consumption is. Then, what is the production power of the solar panel? That is also unknown, but that is actually easy, because the power of the solar panel is directly proportional to its size. The size of the solar panel was this big. Right? So I'm thinking maybe 1 watt. maybe even less, because it looks pretty small. Then, considering power consumption, yeah, it has no chance of working. Correct. It will not work. So that is misconception number 1. The actual power that you get from the solar panel. And I mean realistic power, because you also have to remember that in Jackson, in Wyoming, the day is pretty short. At least the sunlight day is pretty short, because the sun hides behind the mountains. So it may have been already a sunrise, but we don't see the sun for another hour or 2, because it's behind the mountains. Then obviously it's pretty far up north, not terribly, but it's pretty high up north, so in the winter time, because that's probably when you want your Christmas lights, you probably don't want them in summertime, and there's gonna be very little sun in general. And as far as the direct sun, yeah, you're looking at maybe half an hour a day. Maybe an hour. But again, that's probably in the summertime. It is a sunny place when it's summertime. Yeah, it's a beautiful place in summertime, that's for sure. But not in winter. And actually, it's a beautiful place to visit. It's not a beautiful place to live. So yeah, definitely go visit it. You're gonna love it. Just don't try to live there. That town will eat you up and spit you out if you let it. So that's the misconception number 1. Misconception number 2 is how practical they are. So I had this client that wanted to install solar panels on the roof of the barn, but the barn didn't have a roof, so he wanted to use the panels as the roof, right? So they serve 2 purposes: one to be a roof and the other to be a solar panel. That was back in Poland. So one thing you need to know about Poland: we get a lot of snow. Well, sometimes we do, sometimes we don't. Actually, lately, from what I hear, we don't get a lot of snow. And the roofs need to be designed in a way to withstand that snow. So again, if you're in Arizona, that's not your problem. You don't have that problem in Arizona. However, you still have to deal with winds and stuff. And using solar panels as a part of the construction of the building that is again not very practical because there is going to be some maintenance of them. Again, in Poland you also have to consider that from time to time it will hail. Sometimes it's pretty significant to the point where, you know, you get dents on your car, you know, that kind of stuff. So pretty significant pieces of ice falling from the sky. If one of the panels is physically broken in a way that it shorts out, then you need to locate that panel and disconnect it. So at any point you need to have a good access to them. Also, you would like to be able to easily replace it, right? So it's good to have those panels on the ground where you have easy access to them. But to have them on the ground, you need a place like Arizona where you have a desert, and you know, it doesn't matter if they're on the ground or 10 feet in the air or about on top of your roof. As long as there's no shade around, then you know they're gonna produce perfect energy and you have easy access to them. That's how you need to look at the solar panels, the maintenance. Like everything it is, you need to look at the maintenance because it will fail for one reason or another eventually. So that's the misconception number 2, the solar panels being, you know, construction material. Now the misconception number 3 is scalability of the solution. And this is a pretty common pitfall, and unsurprisingly Elon Musk was pushing this idea of building that, you know, the array of solar panels, and I don't remember where it was. I think Utah, or I don't know. Not in the most optimal place, for sure. It's like those, you know, solar roadways built, what was it, in Washington? Why would you even for that to even have a chance of working, it needs to have a proper environment. Arizona, New Mexico, California, not Washington. Anyway, scalability is tough because the solar panel, the last time I checked the prices, that was pre-pandemic. So this might be like completely different now. But the last time I checked, the solar panel cost is about $1 per watt. Of course, if you buy larger panels, it becomes a little more efficient and a little cheaper. If you buy them smaller, it's a little more expensive. But on average, it was roughly $1 per watt. So $100 for a 100-watt panel. So now using that, you're thinking, I get 10 of these and I have 1 kilowatt, which will cost me $1,000. And it will not cost you $1,000. See, connecting one panel seems easy. Connecting 2 panels, it's relatively the same. I mean, it's the slight higher complexity because you have 2 of them, and you can connect them. That's another great thing about them. You can connect them in parallel. You can connect them in series, effectively increasing the voltage. So we can treat them as like single battery cells, and you don't get noise from them. All right, that's another great thing. You get steady DC with no noise, no ripples, no nothing like that, as you would from the regular generator. No electromagnetic noise, no nothing. So 2 of them connected however you want to connect them. That doesn't seem like a lot more that you need to do, right? So it scales pretty well. But to connect 10 of them, that becomes a different kind of problem, because now we need to wire them, right? If you just, because using the linear function, one panel 100 watts, 10 panels kilowatt, 100 panels 10 kilowatts. 100 panels, that means they need to be spread apart enough that you can get to each panel. So again, if they're on the roof, you need to build them in sections. And plus the roof is not going to be huge, right? We're talking house roof. If you build them outside on the ground, then I imagine some kind of rows. Anyways, I imagine some kind of rows, and much like in the garden, so you have access to each panel. Now each panel generates energy, so it needs to have wires connected to it. Then remember that you're dealing with a lot of current. With one panel, you can use say gauge 14 wire. For 10 panels, gauge 14 no longer works, so either you do 10 gauge 14 wires, or you put in a bigger wire, right? Maybe not 10 times bigger, but it needs to be a lot bigger. So with that, it quickly turns out that the cost of the solar panel itself is insignificant compared to the cost of copper that you need to run to get that power from them. Then, even if you went over all those hurdles of scalability and you've built a well-scaled, easy to maintain solution of solar panels, then the problem number 4 remains, which is the most significant one, and that is, what are you going to do with that energy? Well, you can store it, but as far as the energy storage, we're not quite there technologically. We don't have an efficient way of storing energy, electrical energy. There are some excellent ways, like pumping water to the reservoir placed, high up, from a bottom tank to top tank, and then to recover that energy, that water freely floats down to the bottom tank and goes through turbines and generate energy. So you store the energy in a form of gravity, basically. The mass of the water is what stores the energy. But as far as the batteries, we're not quite there. To store it using actual batteries, well, you have two options. Lead acid or lithium, right? You probably won't go to lead acid, because if you do, you need to replace your entire array of batteries pretty much every year. Every 2 years at the minimum. But pretty much every year. Because lead, even if they're SLA, after a year they will lose roughly 50% of their capacity. First year. Lithium batteries, on the other hand, don't. And if you take care of them, they can work for quite a few years. probably as long as the panels do, so maybe up to a decade. Probably after 5 years they will need replacement, because after a decade they will lose the majority of their capacity. But they will definitely store energy better for longer. They are much lighter than lead batteries, obviously, but they're expensive, they're toxic, and they're dangerous. So again, any kind of disaster, you need to have those batteries not placed in the one simple box, because if one battery explodes, starts burning, you have a huge mess on your hand. Remember, when the lithium battery starts burning, there's nothing you can do to stop the process. You're not putting it out. You can pour as much water and foam on it as you want. It'll keep burning because it's self-oxidized combustion, right? It has it doesn't need oxygen from outside to burn. So, and the way to put out fires is to restrict oxygen, right? So you use water or foam or sand or something. And if there's no oxygen, it stops burning. Not with the lithium batteries. They will keep burning. That's why they produce so much energy. That's why they store so much energy, because they're so reactive. So not even not considering the cost, which would be huge compared to solar panels, not even considering the cost, the problems of lithium, of storing energy in lithium, the dangers of it are significant. Oh, come on. Come on, buddy. Get in there. Don't do me like this. Come on, people are watching. Okay, I think we got it. Let's let it cool down and inspect. But it looks like it's straight. It should be alright. Alright, and that is pretty much why, because I have solar panels. I got one 50-watt unit in the garage. What do I use it for? Nothing. After I used it for all my experiments and my, let's call it, research, I have no use for it. Because, well, for it to generate significant energy, I would have to multiply it by 10. That would give me 500 watts. Well, that is something that is actually a significant energy, because 50 watts, not so much. It's good enough to recharge like small battery and maybe some equipment in the field where there is no electricity. Yeah, but other than that, it doesn't do me no good. 50 watts. So multiply it by 10. 500 watts. That's a lot better. Now, for that energy to even be acquired from the sun, I need to place it somewhere. So I need to mount it. I need to build wiring around it and all that. This is one-time investment. So that's good, right? You do it once and it just kind of stays there. You don't really have to maintain much, be it the wires or the panels, unless something goes wrong or you mess up. Because if you mess up the connections, there's heat being produced, as the copper is gonna start oxidizing, and you're gonna have some faulty wiring, and it might not be immediately obvious what is wrong. It's just the panels are gonna generate less energy, and you won't know why. Maybe it's the panels, but it's actually the connections. But provided you don't mess it up, you do it only once, right? Then you need some kind of box that will accept all that energy and recharge the batteries, right? Those are not hugely expensive, depending on the power. For 500 watts, I could probably get a pretty decent one for about $250. Again, all these prices are pre-pandemic. I haven't checked them on them in a while. And again, that is something that you do only once. You set it up and it just works. But then you need to connect some batteries to that charger. And that's where the issues start. The number of considerations you need to have before you place a toxic, explosive material somewhere in or around your house is huge. You need to consider a lot of things. It's kind of like with the hydrogen engines. Beautiful, great, beautiful idea, but not practical because of safety concerns. And the same with lithium. Remember that any kind of leaks, if it leaks to the groundwater, the water you drink, you're gonna get poisoned. So this is not something you want to do on a whim. Just, yeah, I want solar panels, I want batteries, because you can get all that. You can buy it all, and no one's gonna be asking you questions. It's not like there are regulations. This is America, no regulations. You can have electric cars that drive themselves into the ground, or in the other cars, and no one seems to have problems with that. Like where I come from, every year you need to do an inspection on your car, and I know some states also do that. But the majority of states, they don't care. They don't care if your car is working. They don't care if your car is leaking oil. Right? Ridiculous. But I don't know. On one hand, I enjoy the freedom and lack of extra cost of doing inspection every year. I do appreciate that, but on the other hand, I see all those spots in the parking lots where someone parked and leaking oil, and that burns through the asphalt on the road or on the parking lot. Awful, because that goes into the environment. That's not good. That's not good for anyone. Now, if you consider that, let's make an installation without any batteries. We're not going to be storing any energy, so all the excess energy will go back into the grid. That resolves the problem of the batteries. Fine. That would have been awesome if you could connect the solar panels like directly back to the grid. But the great thing about the solar panels in this scenario works against you, because now you need an AC to put it back in the grid, because grid will not accept DC. So now you need to use solar panels to either convert the energy, so you still need to store it somehow as a buffer, to generate an AC signal, and to be honest, to generate an actual good AC signal. It takes pretty expensive electronics if you want the actual sine wave. Normally it's just kind of variation of square wave or square wave equivalent, just like pretty much almost any uninterruptible power supply will generate the square wave on the output, not sine wave, or at least the ones that I've had experience with. And as a repair technician, I've done like literally hundreds of them, and not even repairing them, it's just, you know, replace, because they would come as soon as the battery is dead, and they would use SLAs. They would just throw away the entire UPS and just replace it with something something new, something better, something newer, right? And since I worked for that, you know, utilization or the recycling company, I would literally have stacks of them. But what I would do, I mean, there were some where the IGBT module needed to be replaced, short on the IGBT, but normally they would just work just fine. It's just the batteries were swollen, so sometimes it was kind of difficult to even remove the battery from it. And all the batteries were basically shot, right? They were basically broken, right? So my job was mainly just to replace the battery, and we would resell it. And sometimes even, you know, without the battery. You just have to remove the battery and see if it works. So I would use the oscilloscope to see that it generates nice output, and that's how I know it generates a square wave, not sine. So to generate a nice sine wave, you need an actual generator that will be turning. That's the easiest way to create a perfect sine wave. So basically you would use the solar panels to power the generator to return the energy to the grid. That would be your battery-less, no battery solution, right? You don't need to deal with lithium or anything like that, right? You don't need to replace the batteries. Now, although this would probably work, and I'm sure someone has done that, how practical that is. I mean, you know, you're not gonna be a millionaire doing that. You're not gonna get rich doing that, basically. And the whole idea of getting solar panels and alternative power sources is to have power when when the power company doesn't deliver power. And a few years ago that happened to Texas, right? Nobody was ready for that. There's a great video from 8-Bit Guy testing his rig, his power generation stuff. He's got like a lot of panels, solar panels on the roof, and like crap load of batteries and converters and all that stuff. And his setup is actually really nicely done. He can very quickly switch between the grid and his own power, and it's done very safely, so there's no way to connect both at the same time, because that would not be great. It would probably destroy some of your equipment if that had happened. And he did a test recently, well, maybe not very recently, but some time ago. But that was during like extreme overcast. So the solar panels were generating like next to nothing, right? So it barely lasted for a day. I don't remember how much exactly. Check out his video if you're interested in actual numbers. But it did not survive the period that he wanted. Right, so you might say that it's only partial success, but definitely it is partial success. It's definitely not a failure. It did work, and it worked okay. Look at my joints. It's perfect. The first try. That's good. Because last time I was struggling. What was I saying? I gotta start taking notes or something. Oh right, the 8-bit guy, and doing the So majority of that setup is, it has been set up, and it will just work, right? He will only need to replace the batteries eventually, right? But you can see how much effort and planning it takes, because every job is unique, because it's your house. It's not like there are general drawings of how to install it in general house, right? Every house is different. And now the crews that actually install those panels, some of them are legit, some of them are not. How do you know which one is legit, which one is not? Well, I don't know, but a legit crew will definitely inspect the roof and make sure that after the panels are installed, the roof is not gonna join your living room. Illegitimate crews will just don't care about that. In some states, some cities, you get either tax breaks or even you get partially financed for installing panels, because that's good for the environment. But in any case, it will cost you a lot of money. And you might be looking into like 10 years to get your money back, basically, to have enough savings that the installation was warranted. So it's not like you're immediately off the grid as soon as you install it. Yeah, and a lot of money that you need to put into it. That is a huge investment. So all things considered, if I had an option of going solar or wind, I would go wind. Or maybe some combination of two. With wind, you can do the scenario number 2, where you don't store the energy, just return it to the grid. You can do it pretty much directly, because you will likely get 1-phase or 3-phase AC from the generator itself. And with 3-phase AC, you can do a lot of things. It's a lot more efficient when you get 3-phase AC, especially when you use a lot of power. So all this heavy equipment always uses 3 phases, a 3-phase current, a 3-phase alternating current, which you can connect in a configuration of a triangle or a star, right? Depending on that, you get different energy. Because you basically get different voltage, because in between the phases you get higher voltage than between the phase and the ground. So in the star configuration, everything, each phase is connected, and it all goes to the ground. So you get whatever the voltage you have, maybe 120. Which means in between the phases you get 240, right? So you get higher voltage, so you need less current, so it's more efficient. In some cases, it especially works with devices that require a lot of power, like in a kind of like heaters, like those big industrial heaters, or stoves, or your dryer will likely use the three-phase connector to connect to the outlet, and it uses the cross-phase voltage, so it uses technically 240, not 120, because it's more efficient, because you don't need, because if you require a lot of power, that means you either require a lot of current at low voltage or small current at high voltage, right? Because it's a multiplication, right? That's why the transmission lines are working like medium voltage is like 28 kilowatts, and the high voltage, I don't remember, but somewhere in the hundreds of kilowatts. Because then if you have, say, 100 kilowatts, then 1 amp is 100 kilovolts. Am I saying kilowatts? Kilovolts. So if you have 100 kilovolts, 1 amp is 100 kilowatts, right? So to transmit 100 kilowatts, you only need 1 amp, which means you don't need a huge wire. If you have low voltage and you want to transmit 100 kilowatts, then you need maybe 100 amps at 1 kilowatt, right? At 1 kilovolt, you need 100 amps. So for 100 amps, you need a huge wire. Plus, the wire itself is going to be oxidizing, so it's going to have to be replaced eventually, right? So yeah, that's some efficiency for you. Uh, 600. It's a bit high. It's not alarmingly high or enough to replace it, but this one's around there too, a little lower. I consider anything above 800 to require replacement. So we had one that is closer to 600, 500 and something, and this one 500 something. So these two will need replacement eventually, but also these two are not on the what do you call it? They're not on the frequency side, right? So these are relatively important because they work with these transistors here, and they produce it's basically a buck converter as far as I can deduce. To supply voltage either 5 or 3.3, 1.8 to all these, right, to the logic. So these are important to have relatively low ESR. This one, on the other hand, this one is high and this one is high. These are just smoothing caps. So even if they have high ESR, as long as they have capacitance, it's fine. But again, if they're above 800, definitely replace them, or that's what I do. I'm sure someone will suggest replacement when they're above 200, but most of them usually are around 200. That's why I don't replace all of them. But yeah, technically the ESR we want to see is closer to 50. Right, that's the perfect ESR when they're new. But yeah, that's not enough to warrant the replacement. And the reason I don't just, preemptively replace them when they don't need to be, because again, we need to heat the board, we need to take off some of the conformal coating. We use flux corrosive flags, which needs to be cleaned up. So there really needs to be a reason for that to justify the risks that we take with the replacement. So that's why my bottom line is 800. Let's see the pins. The pins are beautiful. Very nice condition. Alright, Keith, this will serve you well for a long time. That is a guarantee. Alrighty, and now you know what the misconceptions of solar panels are and the problems with them. But other than that, it's a beautiful technology. I love it. I just don't use it. Alrighty, fellas. Thank you very much for watching. Keith, thank you very much for your business. It is heading to you in about an hour when they open the UPS store. Although maybe they open at 8. It's 7:30, so it's definitely not open yet. In either case, thank you very much for your business. And I shall see you guys in the next one.